Dear students, good morning. In the previous videos, we complete the 19 problems of the exercise 3.2 and it is the ninth part of a matrix chapter and 20th problem is given as homework. It is just like a 19th problem and 21 and 22 are the last two problems which are objective type questions. You see, here X, Y, Z, W and P, capital P is there, P, there are 5 matrices with different types of orders. X is 2 by N and Y is 3 by K. And Z is 2 by P, W is N by 3 and P is small p by K. It is small p. Two types are there. It is small p. Here also it is small p. Here it is a capital P matrix. Okay. Now the question is 21. That is, you see, we are given P into Y, matrix P into Y plus W into Y is defined well. Then, which of the option is correct? You see, 21, it is Py plus W into Y. This expression is defined well. It is defined well means there are some conditions for the addition and the product. P is a matrix. What is P? P is the last matrix. You see there. P is the last matrix. Its order is small p into K. It is small p into K. Into Y. Y is the second matrix with the order. It is a 3 by K. Okay, na? Plus W. W is a fourth matrix. 1, 2, 3, 4. It is N by 3. Okay, na? And again Y. Y is the same. It is a matrix with the order 3 by K. Okay, then? Observe. This is the product of P and Y matrix. Whenever you want to multiply two matrices, the number of columns must be equal to number of rows of second matrix. Here also, number of columns is equal to number of rows of the second matrix. Okay. So, here it is, you see, K must equal to 3. But because there must be same number of columns, number of rows must be equal. Then only we can make the multiplication. Here it is defined well. So, K is equal to 3. That is the first one. And you see, here K is equal to 3, we will write here, it is one answer. Option A and D, A and C, both are K is equal to 3. So, we need some more factor. You see, this is a matrix, the product of two matrices again, a new matrix, which is P by K. Here K and 3 will be deleted. And here also W and Y, the product of two matrices is again a new matrix. Here 3 cancels, 3 N by K. It is N by K. If two matrices be added together, then the order must be same. That means P by K must be equal to N by K. That is the meaning. Of course, K is okay. That implies P is equal to N. So here the first option, you see, N is equal to K na? Yeah. And P is equal to N. So that is the correct one. Okay na? Right. Next we go to here N is equal to P, the last problem. Then the order of matrix 7x. I am solving here only the solution 7x minus 5z. 7x minus 5z is, it is 7 into, what is x? X is a matrix with order 2 by n minus 5 into z. Z is the third matrix, is 2 by p. Okay done. Multiplication, okay, let it be. It is that means 7 is multiplied each and every element of this first matrix x, and 5 is multiplies each and every element of the z matrix. So again we get the same 2 by n only. The order will not be changed, but it is 7 times of the element. That is a different one. Here also it is 2 by p. You may feel that, you may doubt, you get some doubt. Where is 7 and where is 5? Means it is it multiplies the element of matrix x. 5 multiplies, it goes inside and multiplies the elements. That is not necessary. But the rows and columns will not be changed. It is 2 by n and it is 2 by p only. It is not 7 2s 14 by n or 5 2s 10 by p. It is wrong. Only it multiplies the elements, but the rows and columns must be same. Okay na? So it is order will not be changed. Here 2 by n and here by 2 by p. But this is addition. Of course, here is negative is there. Okay, difference and sum is both are same. You see, for this addition of matrix, the order must be same. Order must be same. Okay na? It must be same. Means n is equal to p. Here n is equal to p. Okay na? Like that we have to prove. Okay na? Right. And n is equal to p. Okay. But what is its answer? It is a new matrix, it's addition, and it is no doubt 2 by n or 2 by p also, because n is equal to p. For instead of p, I write n. Okay na? Don't confuse. The order must be same. The resultant matrix is also containing the same order. It is 2 by n or 2 by p. But n is equal to p. Instead of p, I write only n. So here is this is the correct one, B option. Okay na? Yeah. Then successfully we solved the exercise 2.1, 3.1 and 3.2. That's okay. Now again a new topic, that is transpose of a matrix. There are many types of matrices we already discussed, and we solved the problems on the types of matrices. That is row matrix, column matrix, square matrix, diagonal matrix, scalar matrix, null matrix, identity matrix, like that. By using that types of matrices, we solved the first exercise. And addition of matrices, multiplication of matrices, we know that definition and we learnt it well. And we solved the second exercise also. Now it is over. Next, this is one more type of matrix. It is a transpose of a matrix. Transpose of a matrix. For a given matrix, there is a transpose. What is a transpose of a matrix means? It's very simple. The rows and the columns are interchanged. Suppose capital A is a given matrix. It is containing the Aij. It is a general matrix. Aij, it is M by N matrix. That means ith row and jth column, M rows and N columns are there. That is a given matrix. Then the transpose of the given matrix capital A can be obtained by interchanging the rows and the columns. Okay, na? And it is denoted by A power T. That means don't say A power T. It is A transpose. We have to pronounce as A transpose. Here also A dash, A transpose, A dash. We pronounce it like that one. Okay, now. Thus, capital A is equal to Aij M by N. Its order is M by N, means M rows and N columns. Then the transpose of the matrix, given matrix capital A is A dash. First of all, it is A dash. A dash is equal to A Ji. You try to note it well. A Ji, not A Ij. A Ij the element, general element in capital A, given matrix. Whereas A Ji is the general element in the A transpose matrix. Okay, now where A Ij is nothing but A Ji. The position will be changed, but the element is as it is. Okay, now suppose one example we will take and we will learn it well. Capital A is equal to 1578. It is a row matrix. One row and 4 columns are there. Okay, na? If we want to find the transpose of that given matrix capital A, is A dash is equal to that one row becomes as one column. 4 columns becomes as 4 rows. Column and row will interchange. But the elements are same. The same 1, the same 5, 7 and 8. But the position is changed. Okay, na? Very simply we can learn it. If rows and columns are interchanged of a given matrix, then it will become as a transpose matrix. Okay, na? Like that. Suppose capital A is equal to A, B, C, D, 2 by 2 matrix. Then it's transpose A dash. Its notation is A dash. A dash is, you see, AB is the first row. It will become as a column, first column. CD is the second row and it will become as a column. Don't confuse them. It is a 2 by 2, here also it is a 2 by 2. The same elements A, B, C, D, here also A, B, C, D. But the position, suppose A is the first row, first column. Here also first row, first column. Here. B is here, first row, second column. But here in the transpose matrix, second row, first column, B, position. Okay, now. There C is a second row, first column. But here C is a first row, second column. Like that. Rows and column. The position of the element of the matrix can be changed. But simply row, column, column, row. But the element is same. That number will not be changed. Okay, now. Then it. One more example we will take. Suppose capital I means identity matrix. I3 I am writing. 1 0 0 0 1 0 0 0 1. It is a 3 by 3 matrix. Then what about the transpose of I? It may also I dash I power T, just like, but don't say I power T. It is I transpose, I dash, I transpose. Both are same. Is the first row 1 0 0. It will become as first column. The second row 0 1 0. The second row will be written as a second column. The third row it will become as a third column. You see that here. Here again we get the same I. Okay, na? Same I. Therefore, I dash is nothing but I. Okay, na? I dash is nothing but I. What are you? I2, I3, I4, Whatever it means. That is the order. Let me read out. The transpose of unit matrix, the transpose of identity matrix is itself. It will not be changed. Okay, na? Like that. Suppose one more example. Capital A is equal to, we will take the limit x, y, alpha, beta, gamma, delta, p, q, and it is R, just like you assume. It is a 3 by 3 matrix. Okay, now? Then what about A transpose? A transpose. When you write T, you spell it as A transpose. Or it is simply A dash. Okay, now? But both are same. In order to get the transpose of the given matrix, the first row will become as a first column. Okay, now? It is first column. And second row will be changed as the second column. And the third row will be changed as okay, the third column. Okay, it is also 3 by 3 matrix. The order will not be changed, but the rows, columns are changed. Okay, na? Like that, okay. Okay, pass. Okay. Transpose of a matrix we discussed and we know it. It's the definition and we solved some examples. Now, the properties. Some properties are there. The properties of transpose of a matrix. Here, a dash whole dash. The transpose of a matrix again transpose. It is A. Same. It will not be changed. The transpose of transpose, double time, A dash whole dash is equal to A. Ka whole dash is equal to K A dash. Means, for K, we will not apply the dash. K is a constant. So it will come out A dash 1. And A plus B whole dash is equal to A dash plus B dash. A plus B whole dash means, for the sum of two matrices, the transpose of addition of matrix, sum of matrix is sum of transpose of matrices. The application for the sum, if transpose applied, it is transferred for each and every matrix. Suppose A plus B plus C whole transpose means A transpose plus B transpose plus C transpose. Suppose A plus B plus C plus D plus E, whatever the number of matrices can you add together. Whole transpose is sum of transposes of those matrices. And here AB transpose is B transpose A transpose. This is a different one. ABC is there, whole transpose. C transpose, B transpose, A transpose. Suppose A, B, C, D, F, G, S up to Z whole transpose means it is a reversal. Z transpose, the Y transpose, X transpose, like that it will be reversal. Okay now? It is in one order, it is a reversal. AB means BA. Okay now? But in our syllabus, the proofs are not there. It is not necessary to prove. Of course, the proofs are there, but in our syllabus it is not. That is why without the proofs we can solve. It is, we have to by heart it. Okay now? But by taking one example, it is important. It is a dated problem. It is a dated, note it well. It is a dated problem. This example is a dated. Here also it is a dated. Please note it. Dated means the previous years this question is asked. Okay now? Now you see, where by taking this example, we will A is equal to, it is 3 root 3 2 and 4 2 0. it is 2 by 3 matrix. 2 rows and 3 columns. 2 rows and 3 columns. B. Capital B is equal to 2 minus 1, 2. 1, 2 and it is 4. It is also 2 rows and 3 columns. First we take the first problem. A transpose. A transpose is similar. 2 by 3 means 3 by 2. 3 rows, 2 columns. That is the first column will be changed as a first row. The second column changed as a second row. The third column it is changed as the row. So it is 3 by 2 matrix. Okay now? A is 2 by 3 but it is a 3 by 2 because rows and columns are changing. Or we may take it as the first row 3 root 3 2 it will become as column. Okay now? First column. The second row 4 to 0 it will become as first column. This is A transpose. Again A transpose to transpose. There is a transpose for A transpose. That means this is A transpose. For this matrix again you transpose. That means the first row will become as first column. The second row will become as the second column. The third row will become as third column. Okay now? It is a interchange, rows and columns. This is nothing but a given matrix same. It is the same. So A transpose, whole transpose is again A. So first is solved. Suppose K A will first we multiply. It is K into what is the matrix A? 3 root 3 2 4 2 it is 0. It is 2 by 2. The K a constant, it will multiply each and every element. That is 3k root 3k. Okay now? And 2k. Here also it is 4k, 2k, 0 into k is 0. Okay now? This is matrix. Now we take the transpose Ka whole dash. That is by definition, if we want the transpose of given matrix, the first row will become as the first column. The second row will become as the second column. Here it is 3 by 2 matrix. Okay now? You see that? In each and every element of this Ka whole transpose, the new matrix is multiple of K. 0 means 0K is there. Okay now? So we can take K as common. This is 3 and 4 root 3 and 2. It is 2. Okay now? It is 2 and 0. Okay now? Now what is it? 3 4 root 3 2 2 0. 3 4 root 3 2 2 0 is already we know it. It is A dash. Okay now? K is as it is. K is as it is. It comes out from the matrix inside the each and every element of inside the matrix. K is common. So we are taking K is common. So it is the matrix is A dash. So it is also proved. Okay now? Ka whole dash is equal to K A dash. K A dash. Okay now? Like that. Now see. Here only we solve it. Here is given third one. Let's see. First we find A plus B. It is a 3 root 3 2 4 2 0 and B. It is 2 minus 1 2 1 2 and 4. Okay now? A plus B. A plus B is the addition of matrix. The corresponding elements be added. Okay now? This is correct. 3 plus 2, root 3 minus 1, 2 plus 2. 4 plus 1, 2 plus 2, 0 plus 4. Okay now? You see this is 5. Root 3 minus 1 will not be added. Root 3 is irrational number. 1 is rational. Is as it is. 2 plus 2. It is okay 4. 4 plus 1 is 5. 2 plus 2 is again 4. 0 plus 4 is 4. So it is 2 by 3 matrix. Yeah. This is A plus B. Then what is A transpose? We know it already. A transpose is 3 root 3 2. Row become as a column. Okay na? And 4 2 0. Will agree? B dash. What is B dash? For B dash also, you change the row as column. Second row as a second column. Okay na? Now what is A plus B whole transpose? Power T or dash, whatever it may be. A plus B, we know it is this one. This is A plus B. Okay now? A plus B means it is 5 root 3 minus 1 4. It is 5 4 4 whole power T. Like that also we can write like this. This matrix is ready to transpose. How can you transpose it? Row will become as column. The second row will become as the column. Okay, Nana? This is A plus B whole transpose. So it is one equation. Next, A transpose plus B transpose. What is A transpose? Is here is that. It is 3 4 root 3 2 2 0. Okay now? Plus B dash. B dash is 2 1 minus 1 2 2 4. Okay now? What is the addition? 3 plus 2 is 5. Simple. 4 plus 1 is 5. Root 3 plus minus 1 is root 3 minus 1. 2 plus 2 is 4. 2 plus 2 again 4. 0 plus 4 it is 4. Okay then? Here root 3 is there. Okay now? So it is number 2 equation. From 1 and 2, same. The matrix is same. So it should be like dash only. So from 1 and 2, we can conclude that A plus B whole dash is equal to A dash plus B dash. Okay now? So it is over. By using some example, we can prove that property. Okay now? Pass. One more example. it is given, we are given capital A is equal to a column matrix -2, 4 and 5. This is a 3 by 1 matrix. And capital B is a row matrix 1, 3, -6. Okay now? This is 1 by 3. It is 3 by 1 column matrix. That is a row matrix. And we verify for AB whole transpose is AB transpose, A transpose. Okay now? First we find AB. It is -2, 4, 5 into 1, 3, -6. It is 3 by 1, it is 1 by 3. You see, be careful. Here number of rows, number of columns. Yeah, it is okay. It is ready to multiply. But the resulting matrix is a 3 by 3. Be careful. It is a 3 by 3, not 1 by 1. Be careful now. -2 is first row, first column. First row, first column. -2 into 1. -2 into 1. That is one element. Leave it. Next, -2 into 3. -2 into 3. That is second, first row and the second column. Next, -2 into -6. Okay now? It is next, second row, first column. 4 into 1. It is 4 into 3. It is 4 into -6. Okay now? Next, 5 into 1. 5 into 3, 5 into -6. Okay? So this is nothing but -2 into 1, -6. This is 12. 4, 12, -24. 5, 15, -30. This is a 3 by 3 matrix. Okay now? Then AB whole transpose. What will be the AB matrix is this one. Its transpose is the row can be written as column. Okay now? The second row, it is second column. And the third row, it will become as a third column. Okay now? Yeah. So it is 1. Now, B transpose. What is B dash? B dash is similar. B is row. It will become as column. This is 3 by 1. And A dash. A dash is a column matrix. It will become as row. -2, 4, 5. This is 1 row, 1 column. Okay now? Now, B transpose into A transpose. B transpose is 1, 3, -6. And A transpose is -2, 4, 5. You see that? Now, it is 3 by 1, it is 1 by 3. So the resultant matrix is 3 by 3 because this 1 and 1 will be deleted and 3 by 3 will come. First row, first column. 1 into -2. Try to catch it correctly. Again, 1 into 4, 1 into 5. Again, 3 into -2, 3 into 4, and 3 into 5 minus 6 into minus 2 minus 6 into 4 minus 6 into 5. Okay, now it is a 3 by 3 matrix. It is minus 2, 4, 5, minus 6, 12, 15. This is 12 and it is minus 24. It is minus 30. So it is a second one. What is the first equation? Minus 2, 4, 5. Minus 2, 4, 5. Minus 6, 12, 15. 12 minus 24 minus 30. From 1 and 2, what we conclude? 1 is a AB whole transpose is equal to B transpose and A transpose. Okay, now like this we have to prove. Okay, it is important problem. Try to catch it correctly. Okay, pass.